Hi everyone, welcome to the castle of the storyteller. So coming straight to the topic, atom. We all know that an atom is so small that can be seen through naked eyes. Only if you are looking through a transmission electron microscope. Let me finish you. The technology behind this amazing invention is to transmit a beam of electrons through a recipient to form an image. So how to cut an atom? Is it possible to cut by a knife? No. We all know that blades and knives are used to cut bigger objects such as tomatoes and carrots. But cutting an atom is not easy as cutting a tomato. The process of cutting an atom is known as fission. In this technology, what they used to do is colliding neutron with the nucleus at the right speed. So why not a proton? Why neutron? Because the nucleus is positively charged and get repelled when getting closer to it. Cutting a tomato is easier than cutting a carrot, right? Likewise, this applies also in the case of an atom. When compared to carrot and tomato, if hardness matters, in the case of an atom, size matters. So the smaller the nucleus, more the energy needed to split the atom. Mike the Iron Tyson is a very stable boxer, right? Like his name, Iron Tyson represents iron is a very stable atom. So atoms with nuclei larger than iron is generally used for atomic fission. Why I said Iron Tyson name? Because it will be very easy for you to remember. And the best example for this is uranium. When an atom is split, it may not always result in two exact halves. So let's take the example of uranium itself. Uranium atom has 92 protons in its nucleus. So when the uranium atom split, it results into an atom of krypton having 36 protons and an atom of barium having 56 protons. This is known as binary fission. Sometimes the atom split into three. This is known as ternary fission. Except uranium, plutonium is also used for atomic fission. Now we understood how to cut an atom. So let's come to the caption. What if you cut down a single atom? The energy released when cutting a single atom is minuscule, and this energy is sufficient only to light an LED bulb for a few seconds. For different elements, the energy releases will also be different. So what are the after effects? How does atomic bombs create such a huge explosion? Let us see. When you cut a single atom, it also releases some stray neutrons, which ultimately result in a chain reaction. So what happens is, these stray neutrons causes the splitting of neighbor atoms too. So by this chain reaction, so many atoms, I don't know how many O should be given for so, maybe more than how many planets present in this universe. When all these atoms split at once, it releases so much of energy which ultimately result in a huge explosion. We all remember Hiroshima and Nagasaki. Atomic energy can be used for various purposes. This including both creative and destructive ways. And the most destructive way is the invention of an atom bomb. Atomic bombs are used only 2 times in history, that too in Hiroshima and Nagasaki during World War II, which leads to the death of lakhs of people altogether. I remember a famous quote by Albert Einstein. Mankind invented atomic bombs, but no mouse would ever create a mouse trap. The entire humanity have to rethink. When coming to the creative ways, atomic energy can be used for various industrial applications such as seawater desalination. The importance of this technology is, as we all know, potable water is not available throughout this world, including many Arab countries having so much of wealth. What's the purpose of so much of wealth when there is not having enough potable water? So these countries spend so much of their wealth in seawater desalination by using small to medium reactors. Another use of nuclear energy is the production of hydrogen. A single 1000 megawatt reactor can produce 150,000 tons of hydrogen per year. District heating or cooling is the another use of nuclear energy because of the larger amount of heat produced by a reactor. Atomic energy can be used in so many other ways because energy is neutral and can be used according to our wish. We have mentioned all the advantages of atomic reactors, but as the coin have two sides, the atomic reactors have disadvantages too. The major disadvantage is the risk that involves in the process. As we all know that it produces so much of energy, what if the process goes wrong? The same atomic reactor will become an atomic bomb. The teleseries that released in 2019, Chernobyl, shows the dark side of nuclear reactors if managed improperly. So finally, let's hear something exciting. Why can't we use atomic reactors in space when it is too far from the sun and doesn't affect us in any way if it explodes too? That's a good idea, right? NASA has already created an atomic reactor that can operate in space, and the most exciting news is it can generate 10 kilowatts of electricity. That means it can provide electricity to an average householder up to 10 years. As the science progresses, there is fewer chances for an energy crisis in the near future, but we are creating more and more efficient ways with more safety. So let's plan for a future that is energy abundant and create a prosperous society. So if you like the video, give a thumbs up and subscribe to my channel. So signing off from YouTube, The Storyteller.